May the 9th, 2025. Guys, you're looking at the satellite tracker app that's on our website, bpearthwatch.com. Check it out. It's been there for quite a while. Scroll over on the right and down, and I think it's a second link on the right down. Anyway, what we're looking at is the Russian satellite called KOSMOS 482, launched in 1972. So we're talking about 53 years. And it was designed to be a Venus landing craft. Well, it didn't make it. Some of the pieces tore apart, and it was stuck in Earth's orbit. And it was it's still in Earth's orbit. You can see it right here. And it's expected to crash somewhere into the planet tonight. Now, it being that it was a landing craft, guys, a Venus landing craft, it was designed to pierce the atmosphere. A lot of satellites, they go up, they go through their launch period, they go through their cycle of being other orbits around the planet. Eventually, they fall back and they burn up into a million pieces. You can see sometimes you can see them fall. But this one was not designed to do that. It wasn't designed to ever leave Venus, I don't think. It was designed to pierce the atmosphere. It's built very well by the Russians, and they don't think it's going to break apart very much at all. But anyway, what we're looking at in the movement of this thing is it's over the South Atlantic right now. This is KOSMOS 482. Notice right here it says KOSMOS 482 descent craft. Now, when this thing failed in its launch, you can see it moving. Back it up, we'll see it's going to come over and around the southern tip of South Africa. Then you're going to see it rise through the Indian Ocean, over Indonesia. It's going to come across. We're going to see it come down through North America, just right here south of Vancouver. This one, earlier as I was setting this up and watching it, it was in this track. Now it orbits the Earth every 89 minutes right now. So the next orbit's going to bring it between Vancouver and Seattle. You can see it coming down over north of Denver, Dallas, and Houston, right down through Colombia and out through Brazil, back out into the Atlantic Ocean at that point. Now, when the thing failed in its launch, the orbit that it was stuck in Earth for the last 53 years has been the low point at 124 miles. And it was an elliptical orbit. In other words, it would dive down to about 124 miles over the planet, and then it would slingshot because of that motion out into space 6,000 miles. And then the gravity of the Earth would pull it back in, and it would do that every 89 minutes. That's about right for some of these orbits. That's a pretty wide elliptical variance between 124 miles and 6,000 miles. But that's exactly what it's been doing for all of these years. Notice right here in the altitude in miles, 117. When I started looking at it this morning, because I know today's the last day, visible day that we're supposed to see it, this thing was in the high 80s right here. And that's a low point. It has not been until this decline started below 125. Now it's rising. See, 118.2, 0.23. It's made its low pass. Now it's going to use that slingshot motion to go back out. It's going to rise in altitude. But each pass, you're going to start to see this number get lower. So your low pass will be approximately 45 minutes, and then you've got a full 89-minute orbit. Now, gives you speed in kilometers per second, 7.79, speed in miles per second, 4.84 miles right there. Now, again, the critical timing or the critical information on here is the timing. And the UTC time here is 16:07.2. Local time, which I think they've got this set at Eastern, is at 11:07. No, it's Central Time, 11:07 right now, 16:07. So they're 5 hours ahead of us. we're going to look at the projected timing that the scientists are seeing. Give me 1 second. Now, this was published 2 days ago. It says the old Soviet Venus lander's fall to Earth will be no ordinary space junk crash. Here's why. It's called the KOSMOS 482. It was built to survive atmospheric re-entry. And this is what it looks like. It looks like a very well-made fan motor, doesn't it, guys, with the blades out here, you know, like a big ceiling fan or whatever. But that's what it looks like. But it's, again, it was a mock-up of the Soviet Union's Venera 7, which for Venus, probe, similar to the KOSMOS 482. The Venus lander is expected to crash back to Earth on May 10th, 2025. Remember, a lot of the timing on this will be UTC time, which is 5 hours ahead of us, Central Time. It says this will be no ordinary space junk fall. It says it will crash to Earth in the coming days after more than 50 years in orbit. Its homecoming may not spark the sort of artificial meteor showers we're used to seeing from falling rocket bodies and other pieces of debris. However, because it was so well built, it's different. As this is a lander that was designed to survive passage through the Venus atmosphere, it is possible that it will survive re-entry through the Earth's atmosphere intact and impact intact. It weighs 1,000 pounds estimated, the part that's left. This is coming from Dutch satellite tracker Marco Langbroek, and he wrote this in a blog post. It says, again, KOSMOS 42 is part of the Soviet Union's Venera program. It launched toward the second planet from the sun in 1972, but never got there. Its rocket suffered an anomaly, stranding KOSMOS 42 in an elliptical orbit around the planet. Atmospheric drag has been pulling the dead probe down slowly but surely over the decades, and KOSMOS 42's time is now almost up. According to Langbroek, the most recent forecast had the spacecraft returning to Earth around 4 a.m. Eastern on Saturday, May the 10th. That's tonight after midnight, before daylight. The uncertainty is quite high, however, with a plus or minus 20.6 hours. It's always that way. And what that does is, in 20.6 hours, guys, it's already made, over a dozen more orbits. So it does drastically change where. Its inclination is 52 degrees, so the craft's re-entry will occur between 52 degrees north latitude and 52 degrees south. Guys, that's a real wide area, by the way. A large percentage of the Earth's surface. Forecasters can't say much more than that at this point, given the large error bars and the timing. These error bars will get smaller and smaller as KOSMOS 482 gets lower and lower and observers gather their data. There's going to be some visible satellite information or telescope information. There's going to be radar information coming in. Right now, though, we can track it. And let's go back to that for a moment. You can see this thing's moving, but again, if you could fly around the planet in 89 minutes, you'd be moving too. But right now, notice the altitude in miles. This, I think, to me, is the most. Now, if you're in kilometers, that's what you like. You're at 203. Same thing with speed. You got it in kilometers per second or miles per second, 483. 126 is just risen back above the 124, which was its low point for all these years. So it's gotten back to that point, and we don't know how much further it will go in the high point. But again, in less than an hour now, this thing is going to be dropping back. And so the key thing is to watch the drops. Like I said, it was right in the high 80s when I started setting up this video, not when I started recording it, just getting everything, seeing what was going on. And so we're just above the low point. So you're going to get a new low point about every 45 minutes. And what we used to do when we were tracking, we've been doing, I guess, 12 or 13 years now, some of these that are falling, is I had kept a list. Now, let me know in the comments of this video, if you'd like, I may put this up live, And then you can come in and comment. I'll maybe put some music in the background and come in and out. But in the comments, people could come over and put the low point. In other words, say in 30 or 45 minutes, you see this thing dropping back down into 80s, starts getting below that 80 section, then you know you're getting into that decline, and we would mark that for years watching this fall. Now, again, I can't, if you would like, we'll put it up live, let it run through this evening, and watch it live if you'd like. But let me know about that, guys. But right now, this is what we have. They're, again, talking about around 4 a.m. in the morning, but 20-hour window, right? So, but we'll know, like they said, as it gets closer and this altitude in miles starts getting lower on each low pass. Again, you'll have a high pass, and that would always be marked, and then the low pass. And those are the two numbers that gives you the data you need, because the lower it gets, then that's when the drag is going to really start kicking in, right? And then it's going to increase the speed, and that will start, the drag will start to bring it down and give us a better idea of where it's going to hit. Now, again, we got a lot of oceans, right? Wouldn't want to be on a major ship with something that weighed 1,000 pounds barreling in like that. And because it's going to remain a solid object, it makes it that much more dangerous in a smaller area. I just wouldn't want to be there. If you see it, look up, you see it coming, duck. It's a heads up, guys. Be safe.